Hello, I would like to present to you my final project. I'm Hyunwoo Yoo, and I will give you a brief introduction of my topic. Today, I want to portray to you the effect of geography on the spread of COVID-19 or any viral pandemics in general. Okay, first, I want to present to you about my analysis on the data that predicts the daily cases of COVID-19 by region. I chose this topic to identify the rate of the COVID-19 contractions by patients with respect to the geographical region. Data collection process. I found this data at healthdata.com. Healthdata.com contains a lot of health related data. Here are three data sets and links. And as you can see, the form of the first file is CSV, the second one is JSON file, and the last one is an HTML file scraped using Beautiful Soup. I chose these specific data sets because they portray the effect of geography on COVID-19 spreading very clearly. It labels each state with region codes and FIPS codes, which allows for easier sorting and categorizing within the datasets. Data cleaning processing. In our first dataset, I first check for unique values in categorical columns to flag any garbage categories. Then, I check for null missing values and found that there are missing values in geocoded state. As using mean or mode on geocoded state would not make sense, I have dropped these missing rows. Then I check if state code and state names are consistent. After that, I look for negative values in numeric columns and found that new results reported contains negative values. I resolved this issue by resetting them to their default value of 0. Similarly, all these checks have been applied to other two datasets and checked for any inconsistencies. So, I discovered a total of 6 inconsistencies and I cleaned them all successfully. I have used Pandas library function for cleaning and exploring data like fillNow, isNull, strip. Data analysis, insights, and visualizations. In our first insight, I have aggregate columns to show region, year, and quarterly total results reported. This shows which region is getting infected more badly and which is recovering from its previous quarter rate. The column total results report shows new cases reported in that quarter. It can help in deciding which regions need the most medicines and precautions. The graph displays the total number of cases reported by region. The second insight shows aggregate data with respect to states and their overall outcomes. This insight showed the connection between the results of PCR tests and its respective states. It also shows the number of people that are safe or recovered. It can play a critical role in drawing conclusions for determining safe and hot zones in the future. The third insight shows a table of new death cases with respect to states, year, and months. This shows state death toll over the time period, which state death toll is increasing and which is decreasing. It can help in deciding where to provide emergency supplies and healthcare machinery. The graph shows death trend over the months of 2020 in different states. The fourth insight shows information on max population state where the most tests have been conducted, where the most active cases are remaining, in which state the most people have been recovered, where death toll count is max, and where the most cases have been reported. Similarly, all the mean values too. This information is helpful in marking red and safe zones. The final insight shows a table with added columns, percentage of total population infected and how much of that is recovered, still infected and number of deaths in percentage. This information shows status in percentages and can help in estimating the overall figure of the test state. The graphs show overall status of California and Texas as California has the greatest number of cases and Texas has the highest recovery ratio. I have used Matplotlib library for visualization and plotting data in the form of bar charts, pie charts, and line graphs. Conclusion. Looking at the dataset, I can see that the spreading of COVID-19 is correlated to the geographical region. Due to the nature of pandemics and viruses, the region affected by COVID-19 are showing signs of spreading and rising cases. With some of these insights, I can identify that population density will have strong correlation with the COVID-19 cases in the dataset. Thank you for watching my presentation. Thank you.